Hi guys, it's Mrs. Jackson. Today we're going to start our next topic in chemistry this year, and that is chemical reactions. This is where we're going to put all of the skills that we learned writing formulas into practice writing our chemical equations that are going to represent chemical reactions. We're going to start to look at things that will be more of what you imagine chemistry to be in your mind. So all of those things that happen in lab, this is where that begins. So be sure that you've got your periodic table and that you have the notes page that was provided for you in Schoology. Have all your materials ready to go. If you don't have access to a printer, it's no big deal. You can take notes on your own paper. That works just as well. So let's go ahead and get going and start our conversation about chemical reactions. One of the things that you have to know about chemical reactions is this is where we can rearrange atoms. We can bond them with different things, but we don't change what atoms we have. We just may break them apart from their partners in one molecule and rearrange them to connect with atoms and form a new kind of molecule. Sometimes we will call this a chemical change. There are 5 signs when we are in the laboratory that a chemical change has occurred, and you need to know all 5 of these. Okay, the first one that you see listed here is a change in energy. That can be heat, so the temperature could go up. Okay, we could mix 2 liquids together and the temperature gets warmer. We could mix 2 things together and the temperature could go down. So that occurs as well. That's called an endothermic, when the energy is absorbed into the system, or it gets cooler to the touch, or it can get hot to the touch, which is called exothermic. The energy is exiting. The other way that sometimes we will see a change in energy is the giving off of light. So you can think of fire, for example, which is a type of chemical reaction, gives off both heat and light. The glow sticks that you see very commonly at Halloween and so forth, that's giving off a type of energy in the form of light. So a change in energy, either up or down, is an example or one of the pieces of evidence that we use to verify a chemical change has happened, that our atoms have rearranged. The second one is a color change. So this is a true color change. So when I burn the wick of a candle, it goes from the white yarn color to the black color that indicates combustion has occurred. A lot of things that we put into some of our acid-base chemistry, when we start to look at that, we use indicators. Well, they change color when the pH changes, and that tells me that a chemical change happened, even though I couldn't see it with the naked eye. Color change does not include taking something like an orange colored drink like Tang or Kool-Aid and adding that orange colored powder to clear water. That's still orange, so that's not a color change. Color change really is truly a new color that was not present in either of the previous compounds. Change in odor, so when things change smell. When you cook, for example, if you are outside during the summertime, you notice that someone's cooking on the grill because you can smell that from a distance. That smells a lot better than the raw meat, so a change in odor. The second one is the appearance of gas or bubbles. So sometimes if you drop Alka-Seltzer or some types of cold medicine into water, they start to fizz or effervesce. That is the production of bubbles. Boiling does look like it's producing bubbles, but boiling is a phase change, so that does not count in terms of the production of a gas. And the last one is a new term, the production of a precipitate. And this is really a solid. We can mix 2 clear liquids together and we can get a solid to form. It's a very powdery solid, so usually it turns the solution kind of a cloudy color. But precipitate looks like the word precipitate, which it is. And precipitation in terms of weather is stuff that falls from the sky. In chemistry, precipitates are solids that form and then sink to the bottom of the beaker. They fall kind of out of solution. So you need to know all 5 of those. So get those down in your notes, please. Remember, you can pause and replay this at any point you need to review anything I've said or I didn't speak clearly enough and you need to hear it one more time. All right, so generally speaking, this is the format of a chemical process. We've got the reactants on the left and we have the products on the right-hand side. Reactants are the things that we begin with, that we bring together or react together, and what they form are called products. So the reactants react together to produce a new substance or new substances that we call products. And this is how we write a chemical reaction, okay, on paper. So this is called a chemical equation, and this is what we use to represent that a chemical reaction happened in a reaction vessel, like a beaker or a flask. Be sure that you know the term reactants and products. Be sure that you use them correctly and you understand which side of the process or the chemical equation that they appear on. All right, here's some punctuation, if you will. So we're learning to essentially write chemistry sentences, and our chemical formulas that we just learned how to write will be our words. The chemical equations will be our sentences. And these symbols that are listed here are what we use as our punctuation. They give meaning to the symbols that we write. The forward arrow simply is between the reactants and the products, and it means yields. You can write in your notes it means produces, but this stands between the reactants and the products, and it shows us we began with reactants, okay, and they changed into, or they formed, or we have now a yield of products. All right. This reversible arrow, you won't see a lot this year, but the seniors are using it a lot this year. And this means that the reaction actually can go either direction. That means it's reversible. If you happen to see a little s in parentheses, that means that whatever that substance is in the solid state of matter. So it could be that precipitate, like we talked about earlier. It could be a piece of magnesium metal, which you will see in some of the videos. It could be a piece of sodium metal. It could really be any solid substance. This down arrow is sometimes used to indicate solid, but this is only used if we have a precipitate form on the product side. So you won't see this one very often. You're going to more often use just the S, and that can be used either on the reactant side or the product side. If you see an L, that means that the reactant or product is in the liquid state. This applies very frequently to water, but sometimes we'll see water in the gas phase also. But an L means liquid. I'm going to skip down to the G, which means gas, here at the bottom. That's what we would use for the bubbles. Obviously, if we had carbon dioxide or oxygen gas, some of those very common gases, we would use the little g. And then we have this new one right here, the AQ, and that AQ stands for a substance that we dissolved in water. The abbreviation AQ comes from aqueous solution, but it means that that substance has been dissolved in water, because a lot of solids, for example, sodium chloride, some of our other common salts, they actually won't react unless we dissolve them in water first. And so this is one that we use an awful lot, is that AQ. Be sure you have all of these down on your paper. Be sure that you understand them and that you recognize and know what they are. One note, sometimes for gas, sometimes you will see an arrow pointing up, meaning that gas has bubbled and come up out of a solution. We don't use it very often, but if you happen to see it, that's what that would mean. All right, so now we're going to start looking at the 5 kinds of chemical reactions that I need for you to know. I'm going to give you some examples. I'm going to tell you what to look for, and then after you finish the video, you've got some practice that you're going to work on. All right, so these are the 5 types of chemical reactions that we're going to look at. We're going to look at something called synthesis or combination. Those words are used synonymously, so synthesis synthesis or combination. If you abbreviate the word synthesis, you need to use SYN. Please don't abbreviate the word combination if that's how you choose to name them. You need to write that word out. I'll tell you why in a moment. Another type of reaction is decomposition. This is when something breaks down. You're going to abbreviate it decomp. Single replacement, we're going to look at some examples. Those are called or abbreviated SR. We have another type called double replacement. These actually look like they're the hardest ones to work with, but it's very misleading. They're actually the easiest to work with. When we talk about acid-base reactions, those are a special type of double replacement. The last type of reaction I need you to know this year is called a combustion reaction. And combustion is what most of you guys are going to think of as fire, but it's actually a little bit more broad of a term than that. So be sure you've got those down and identified, and we're going to start looking at each one of these, and I'm going to tell you what to look for so you can classify any reaction that you see. All right, first type we're going to look at is called the synthesis or the combination reaction. Okay, this is defined as two different substances coming together and forming only one product. So the real look for here, so if you've got to find something that you're looking for, it's the formation of only one product. There's only one compound on the right-hand side. It's always a compound. Okay, it's always going to be multiple atoms pulled together, and there's only one on the product side. So that's going to be how you recognize synthesis. Synthesis means to form, and so these two things here are coming together to form one single piece here. I could have two things. Honestly, guys, you could have 3 or 4 reactants, but the thing that you will always know makes it a synthesis is there's only one product. Okay? The second type that we need to look at is decomposition. This looks like one reactant breaking apart into 2 or more different products. So I start with one compound and it breaks apart and I have more than one product, all right? So the look for is only one compound listed on the reactant side and it breaks apart into several things. It could be 2, it could be 4. All right, but the look for is only one kind of reactant. Next in our conversation is the single replacement. What happens with a single replacement is that you've got on the reactant side, you've got an element. It's usually a metal. It could be a halogen, and it's by itself. You also have a compound, and this is usually, I can't think of an exception, so this is an ionic compound. And what happens is this red square or this reactant simply replaces one of the other particles in the compound. So I am replacing one thing. This single thing replaces the green triangle in our example. You can see on the product side that the red square and the green triangle have traded places. Okay, and that's a single reaction, single replacement reaction. The trick is something has to start off single, and at the end, something is still single. You always have an element and a compound, and an element and a compound on each side. The next one to look at, double replacement. This is like, well, this is when 2 ionic compounds just switch partners. These look hard, but they really are going to be super easy. So what happens is, this is like going with your friends. Maybe you're a couple and you have a friend, a set of friends who are a couple, and you go out, and if you're dancing, you start dancing with your partner, and your couple friends start dancing with their partner. But for one dance, you trade partners. So the square, instead of dancing with the heart for the second dance, is now going to dance with the blue circle. Okay, and when they traded partners, then the triangle traded partners and will dance with the heart. So you always have 2 ionic compounds on each side, and all they do is they trade anions, right? We're going to look at some specific examples in just a moment, so don't panic too soon. Okay, the last example that we're going to look at hydrocarbon combustion, but combustion's actually a little bit bigger. Combustion's, I think, the easiest to recognize, but it sometimes is tricky for some students. What you're going to look for is a hydrocarbon on one side with oxygen. So this is just like the fire, when the firemen came to your classroom and you learned about fire safety, you had to have a fuel, you had to have oxygen, and you had to have a spark. This is true for combustion. Our fuel is going to be this hydrocarbon. Don't overthink it. Hydrocarbon means it's got carbon and hydrogen, right? Not too hard. And it has to have oxygen to react. So those will always be your reactants. And then when they react, you're going to get carbon dioxide. Sometimes you will get carbon monoxide. We'll talk about that later. And you always get water. So it's a very predictable product set that you get when you have combustion of a hydrocarbon. You either get carbon dioxide or carbon monoxide with water, and that's it. Okay, so those are your 5 types of combustion reactions that you, or I'm sorry, 5 types of reactions that you need to know. Synthesis, where I form one product. Decomposition, where I start with only one reactant. Single replacement, where a single element trades places with another element. And double replacement, when 2 elements trade places. Okay. Those are the 5 types. Now that we have finished the quick notes, you can start going into the rest of the note document, watch the videos that are provided, and finish completing the questions that are asked of you. We will meet again and talk through the information to be sure you don't have any questions before we move on to balancing. Thanks. I'll see you soon.